I'm Dr. Danelle DeGowan, and it is my pleasure to be speaking with Dr. Peter Bretscher today. Dr. Bretscher is faculty here at the University of Saskatchewan in the Department of Biochemistry, Microbiology, and Immunology. He and his students have made substantial theoretical and experimental contributions to the field of immunology. Most notably, in 1970, he published with Melvin Kahn the two-signal model of lymphocyte activation. And I want to tell you a little bit about Dr. Bretscher's vision. He has said, "My youthful dream was that discussing science would be like playing really well in a quartet, where the music is divine and one's own contribution so fused as to be unknown." So good morning, Peter.
Good morning, Donalda.
Can you tell me a bit about the book that you've written?
Certainly. So I've been doing research in immunology for 50 years. And I came into immunology after studying physics. And I studied physics because I really felt that there were simple laws governing nature, and the same thing would be true in biology. And so I've been inspired during my 50 years in immunology to try and find such fundamental laws. And I feel that there are fundamental laws, and that the foundations of immunology are very important. Because if you want to intervene medically, either by preventing a disease or treating it, you have to have the correct foundations and framework. And I think that if you do have the correct framework, you can actually devise medical strategies which are non-invasive and really efficient. And that's one reason why I've written this book.
Okay, can you say more about what areas of medicine this information is pertinent to?
Indeed, yes. So the immune system is very relevant in fighting infectious diseases. In autoimmunity, those are situations where the immune system starts fighting part of the body to which it belongs rather than foreign invaders. In allergies, in cancer, which the immune system recognizes as foreign, and also, of course, in transplantation.
Mm-hmm. Interesting. What circumstances led you to write this book?
I had a heart attack 13 years ago, and I was in intensive care for three days. And during that time, I naturally looked back on my life and came to realize that I wished I had done some other things. Particularly if I had died. On the moment of dying, I'd have realized I'd had some regrets. So as a result of this incident, I resolved to do some really different things, and writing a book to explain immunology and my philosophical attitude to knowledge was the main one.
Now, do I understand that you felt some urgency with respect to some of the existing foundations in immunology?
Yes, I mean, my realization of what I wanted to do was because I felt that there were two really major questions in immunology. These were questions which were really important for devising strategies of medical intervention. And I thought the frameworks employed by most immunologists for the last 2 to 3 decades were wrong. And when you have wrong foundations or wrong frameworks, everything seems very complicated. And I thought that I had partial solutions to these questions, providing foundations which made things much more simple and understandable, even understandable, I believe, to non-specialists.
Okay. Can you say a little bit more about how you got into the field of immunology?
I was doing graduate studies in an area called protein X-ray crystallography, which is really applying physics to understand the structure of very large molecules. And during that time, I had an accident. I was wearing gloves, and a very nasty chemical leaked through the gloves and actually reacted with my fingertip. I hate to show it, but here it is, this fingertip. And the immune system recognized my fingertip as foreign, and it started a process of rejecting it. And there was a very sharp line between my altered fingertip and the healthy tissue, And that got my interest in how the immune system fights foreign invaders, but doesn't, and manages not to fight part of the body to which it belongs.
Interesting.
So I sort of saw that process going on, as I said, at my fingertip.
Interesting. Can you say a little bit more about your early days as a student?
I was I studied physics in Cambridge. There was a lab in Cambridge where some chemists and physicists got together trying to apply chemistry and physics to understanding the basis of life. And this became an extraordinarily famous lab. And one of the most famous people there was Francis Crick, who was a co-discoverer of the structure of DNA. And he had in his, outside his office on his notice board, he had actually a little card saying, if you want to discuss science, please enter. And when I started getting interested in immunology, I plucked up my courage, knocked on the door, then realized for the first time that I did stutter under certain circumstances. But in the end, we got together discussing ideas I had. And I must say, Francis Crick was incredibly encouraging to me and gave me confidence that reinforced my vision that actually you could think in a very fundamental way about biology.
That's wonderful. Can you tell me a little bit more about your work?
So the two questions I alluded to before, which I think are very, very foundational and very important for providing a framework for understanding for developing strategies of vaccination and other medical interventions of prevention or treatment are the following. The immune system has a way of fighting all the foreign invaders. And the remarkable thing is it doesn't fight your own cells or molecules which are part of the body to which the immune system belongs. And that attribute of the immune system is called self-on-self discrimination. So that is one of the two major issues I was really interested in. And you might imagine that if you understand self-on-self discrimination, it means you actually understand how you turn on responses, immune responses, and how you prevent them from occurring. And if you really understood that, you might have a good chance of preventing or even treating autoimmunity like autoimmune diabetes or multiple sclerosis, which are examples of autoimmune diseases. So that was one question. The other question is, the immune system has the remarkable ability to fight foreign invaders, but it doesn't always choose the same means. It has two major different means, and you might think that the immune system would use all the weapons at its disposal to attack a foreign invader, but it doesn't do that. It has a decision-making process. It uses either that mechanism, antibodies, or another mechanism, cell-mediated immunity, and sometimes it can use both. But it certainly has this decision-making process. And a lot of medicine, or clinical conditions rather, arise because the immune system uses the wrong means of attacking an invader. And so the question I've been very interested in is, how does the immune system decide what type of means, antibodies or cell-mediated immunity, to attack a foreign invader? And we've really made great progress, so much so that we can control whether one means is employed or another by vaccination. And we can even change, once a decision has been made, how to attack, so that it attacks a different way. And so these are the basis for why we believe foundational ideas can contribute to strategies of prevention and treatment in medicine.
Okay, terrific. What are your hopes for this book?
My hopes are actually that a lot of people who think science is a very complicated field can read this book, which is only 180 pages long, and here is the book. It's called Foundations of Immunology, and it's Pertinence to Medicine. And this book is very big type, so 180 pages with very big type. It doesn't make it so heavy, but it's actually written so that someone who really doesn't know even modern biology can understand it. And I must say I was very pleased that a reviewer who normally reviewed children's books was kind enough to give it 5 stars. So I hope it really is understandable. But more important than that, I want people to realize or to become empowered in their own thinking that it is possible to understand what appear to be complex things in a simple way, and therefore to realize that they don't have to be complex. And that actually is really the biggest motivation for writing this book.
Terrific. That's quite a challenge, and you've done well to do just precisely that. So thank you for answering my questions today, and I look forward to reading more of your work.
Thank you very much, Donalda. And I want to thank, I have a student who's doing graduate studies with me, and who's also doing an MD at the same time, and who also has a side interest, one of many, I might add, of filming, and he has very kindly taken the effort to do this for me. So thank you, Donald, and thank you, Ghassan.